有没有人听说过边缘计算，或者正在做边缘计算？Please raise your hand if you are doing edge computing. And how many of you heard of KubeEdge project, or how many of you are using KubeEdge? So not many are using it. So today, I would like to give you a general introduction about this project. And I hope you can go to our website for more information. So I would like to start my presentation. Self-introduction, I'm Wang from Huawei. And now I'm leading KubeEdge project. So actually I already asked you these questions. I'm sure you're interested in edge computing. So I will go through the main content directly. First of all, edge computing is a very hot domain after cloud computing. There are special benefits with edge computing. Of course, there are also challenges. First, the network is not really stable between the edges. Sometimes it's a public network or some private networks, and there's limited bandwidth. And all the nodes and the devices on edge is in a large number. And if you are in the scenario of industrial control, there's a heterogeneous hardware and protocols. And also the devices on edge is quite small, so the resource is constrained. And maintenance cost is a challenge. But your data request can be sent to the edge and come back quite quickly, so you can achieve data locality and security. Compared with cloud computing, it's more secure. About KubeEdge project, there are several pieces of key information. KubeEdge targets to edge computing with Kubernetes. In March this year, KubeEdge is accepted by CNCF as a sandbox project, and we're incubating this project. So the main feature is to achieve synergy between cloud and edge. So our main idea is that edge is the extension of cloud. A lot of vendors already have existing and strong service on cloud. So if you can connect the cloud and the edge, users can enjoy more comprehensive service and also enjoy the fast and localized service on edge. Yesterday we released KubeEdge 1.0 version. We already had 4 minor releases. And in our white paper, it's listed as reference architecture. Now there are over 100 contributors in our project. Or we should say over 100 people have contributed to our project. There are also a lot of companies contributing, including cloud companies in China, such as China Mobile, and also international companies such as Intel. They are all our contributors. This is the community activity in the past 6 months. The data on the left is quite small, but generally speaking, it's quite active, and the level of activity is increasing. And the 1.0 version and the previous release introduced the support for some edge devices, and I will give you more details. This is our vision and mission, or our goals. As I already mentioned, this is the edge computing platform based on Kubernetes. So we hope we can use the primitive method to manage the nodes on the cloud. So we hope we can adopt the same method to manage the nodes distributed on the edge, and as well as the applications on the edge, and as well as the connected devices. We hope this kind of management is can be used across different fields. So that means including cloud or edge. And we also would like to manage KPI. It should follow the design style of Kubernetes. And we also need to support Kubernetes primitive native API. And in terms of scale, we would support massive number of nodes and devices. This is the latest KubeEdge architecture. So the edge part is enlarged. The part of cloud is presented quite simply. The main controller is edge controller. Its main function is to do shadow management on edge. For example, your node is not on edge, but the pod is scheduled to the edge. So we use the edge computing and use edge controller going to write the latest information of these applications to Kubernetes server. So other components can see the pod and the node and their configure mode, so they can be processed using the same method as on cloud. So in order to achieve the coordination between cloud and edge controller will send the message to Cloud Hub. Cloud Hub and the Edge Hub are based on WebSocket. We know when you create connection on WebSocket, it can achieve two-way communication. So the nodes on Edge can be in a private network. You don't need a public IP. As long as you can access the Cloud Hub, you can consistently communicate with cloud, and it's both ways. In terms of edge device management, we achieve device management or device twin. In some edge computing platform, there's also concept of device twin. So when you have a device, you can control the device through device twin, and you can map it on the cloud. And we can change some commands on the device twin to control the edge device. So we achieved the mapper, decoupling of mapper, because on edge there are many different types of device. And a lot of scenario use MQTT, but other devices use Bluetooth or model pass or OPC-UA, which is Industrial Control Protocol, and many other protocols. So device vendors may have new protocols. In KubeEdge, we also embed Bluetooth, Modbus. Of course, MQTT is embedded already, and HCO. And if a device vendor would like to add more protocol, they can create a mapper. So they can have abstraction of the communication. And now, currently, MQTT is communicating with Event Bus. And Event Bus is MQTT client. It can also communicate with the device on edge. So this is the implementation of Kubernetes. After some analysis, we find native Kubernetes has a lot of functions. For example, the pod is not really needed on edge, and a lot of built-in storage is also not necessary. So we decided to rewrite lightweight Kubernetes. There's also meta manager, which can consistently manage the metadata. And lightweight storage is syn to light. So after synchronization, the meta manager can write the message in the lightweight storage. We know Kubernetes doesn't have consistency of metadata. So if there's breakdown, the product from the cloud will not be recovered. But after our consistency, even if in disconnected scenario, after the node is recovered, the pod and other data can be carried over. And the device twin is responsible for controlling the information of all the devices, and a copy is saved on the consistent storage of edge. Event bus is to control HTTP. Some devices are exposed, the portal is exposed through HTTP. So in this box, edge part, it's a one binary, and the overall memory is 10 megabytes. So even if your memory is only 128 megabytes, it can be run. So the resource consumption is not just this component. The MQTT broker and the Docker supported in the first version. Then the resource consumption may be over 100 megabytes. And now we are doing the support for container D, and we will continue to support more lightweight runtime. And we also introduced a key feature, that's edge mesh. It's originated from the concept of service mesh. And the main purpose is to achieve the data communication capacity across edge. In the early version, we could only access the IP portal or URL. We couldn't have service discovery, etc. Actually, Edge Mesh is the edge computing service on Kubernetes. And in current version 1.0, we can't have cross-network edge-to-edge communication. So the 1.0 version relies on the connection or connectability of the various edges. And then we are going to connect private networks and also the communication with the cloud. It's going to be a very important way of communication. And also in 1.0 version, in the early version of KubeEdge, the more support was given to edge device. For CDN or other station on edge with a strong computing power, there was no specific support. In the KubeEdge architecture, each connection is directly connected with the master. So when the node is broken from the master, there is no capability for dynamic transfer.
They have the requirement for the scalability of applications. So in 1.0 version, we introduced edge side. So we have synced Kubernetes master to the edge, and after that, Club Hub and Engine Hub is not that important anymore. And more importantly, for master, when it go down to edge, if master is in different network with node, how can we connect it? So in the later versions, we will support through Edge Mesh, because Edge Mesh has just launched and Edge Side has also just launched, and they have not connected yet. In addition, this is a traditional version, a transitional version. So at that time, we use this kind of a mode, but the problem is Docker consumes a lot of resources. So in the 1.0 version, we add the CRI interface back, and then we have the verification of containerd integration verification. And now we are in the alpha version. You can have a try, and later for the Docker tools, we will eliminate it, and all will be supported by CRI, and later we will use CRI-O. So in terms of resource consumption, it's lighter. Another one is the evaluation framework of what we have done. For example, we haven't released all the data yet. Before 1.0 version, we have a framework for the performance, and this framework is pretty easy. We use 2 layers of Kubernetes The lower level is Kubernetes. Every pod will regard it as edge node to simulate all the nodes in the edge, and another one is independently deployed Kubernetes and KubeEdge component on the cloud. So through these two layers, we can simulate a huge amount of edge node deployment. Actually, through our evaluation on the design for the communication between cloud and the edge, we use Edge Hub. At the edge, they can do convergence of messages between nodes and synchronize it on cloud. So what's different from KBus is that the nodes connecting will be reduced, and in the function of Kubernetes, API servers communication data volume will influence its scalability. One way is to ensure the same amount of connecting node, and you ensure the data volume and to ensure the scalability. And second, if your communication package volume cannot be changed, then you ensure the long connection. You can also ensure scalability. So I think for KubeEdge, compared to native Kubernetes, it will have a better scalability. For this framework, it will validate our hypothesis. Currently, we have some people from the community. They have tested 4,000 nodes, but it's only a reference. In terms of performances, in terms of communication between cloud and edge, we are using WebSocket. Between Cloud Hub and Edge Hub, we are using WebSocket. And we are studying QUID protocol. We have version based on QUID, but the performance is on evaluation, and in terms of performance, it will improve a little bit. Next is the application scenario. For KubeEdge, we use the core part of Huawei Cloud computation and make it open source. Apart from KubeEdge, we have the Huawei Cloud service, and the application is in a smart park. The main demand from the customer is that they want to do the facial recognition, and they can identify the people's ID, and at the gate they want to monitor the traffic of the park as well. And for the camera, they do not use smart camera. They are using traditional IP camera. You use IP address, you can read the video flow. So overall application is pretty simple. So we use facial recognition and the traffic flow and synchronize it to edge. As we all know, at edge, an original video flow have a big data volume. If you have an application on edge, in the video frames, you only capture a small picture of a head side. You make a comparison, And the comparison is based on your business design and whether you want to build a big data cloud mesh or you just make it on the edge. In the initial scenario, the client, they use the central big data model in cloud. So their facial recognition is on cloud. And for the edge, they will catch a picture of head size from the video and upload to the cloud. And based on the head image, they can do the face detection. Another case is a case for CDN customer. It's not using each side, and the user, their main CDN is for ordering of videos. Generally, the case is to send a video from central cloud to the edge. And we slice the video. When you watch the video, actually, you can see, you can adjust, you can change, and you can adjust the pace. So you need to do slicing, and then you need to shift the code, and then maybe your coding may be different from the original video, and you also need to provide the flow media. So we can make it directly connect to the cloud, and then it can also do we can run video transcoding, rendering, slicing at the edge, managed as job and deployment. Let's take a look at the roadmap of the project. Actually, we started from November 2018, and we announced the open source of this project, and we provide a lightweight. We are lightweight agent at edge, and in the past versions, we provide support for the edge equipment and also support the synchronization of the state data, synchronization of state, and we also have a mesh layer for the communication between cloud and edge, and we also support CRI and containerd integration. At 1.0 version, we need to further do CSI because in the current version we deleted a lot of storage type support. In the edge, we do not have AWS storage, but for the clients we met, they still need the demand for external storage, and they also want to have cross-edge data sharing. So before 1.0 version, we already have done CSI and storage compatibility, but we do not have enough headcount to further work on it, so it will be done later. And we will also have some remote control functions so that you can monitor the edge status, and we will further optimize the openness of the community. Also, we have over 100 contributors, but through previous survey, people think that to become a contributor, there is some threshold, and we will further increase the guidance of files so that people can contribute to it. Due to time limit, previously I planned a demo, but I will not do the demo here. But you can go to our booth and take a look. And for the demo is pretty simple. Through KubeEdge, how to achieve the control of equipment or have a communication with the equipment. And here WeChat is just a portal to enter, and it's mainly on the cloud, and we have a web server. Through web server, you can select a song, and a KubeEdge WeChat app will write the song name at Kubernetes master. Then we will synchronize the equipment update to the edge, and then we will connect to a Bluetooth sound amplifier, and then we can receive topic message from the subscription and play music by the track. So just to show you how to add the definition of equipment and how to update the equipment status. And for the demo, you can go to our Huawei's booth, and I will not show it here. And the last part is about the basic information of our community. You can see our website, and we have Slack channel. And for every 2 weeks, we will have a meeting, and we will upload the meeting video to the YouTube. And for domestic or Chinese friends, you can scan the QR code and you can join on our group, and we can have a further communication in the group. So any questions from the floor? I want to ask why you choose to build an HD, because after evaluation, we think if we want to simplify or remove some kubelet, then we need to cut a lot of code. So we decide to write by ourselves. My Chinese is not so good. I will speak in English. 我看到你的路线图，你们有，比如说，就是后面的路径的话，有1.x 的版本，你如何做监控呢？现在的话，基本上你可以看到应用的状态，但是这个是不够的。我们想要支持Matrix API， 然后你可以体验类似于像 Vanilla Kubernetes 这样的一个体验。因为现在如果你用Prometheus， 那是 broken。我们在 KubeEdge 里面没有，在华为云里面，这个我们里面有一个项目，但不是开源的，我们需要把它做到开源的项目里面去。Sorry, he's not using microphone. The interpreter cannot hear. I will repeat his question. First, the first question is about edge nodes management, how to provision nodes. Actually, for the KubeEdge project, we do not do it fully because in edge ecosystem, some other projects are taking care of it. Currently, our starting point is that the edge nodes need to focus on OS, and the KubeEdge release pack, we have an installer. It can help you to install the components in the edge node. For adding nodes, you can add it manually. You can register on cloud and create node object and edge core. Then you fill in the Cloud Hub information. And for security, we have very fundamental certificate-based security. We will have a hierarchy security design. We have a prototype now. We have some discussion in the community. The main idea is that we will use spec in cloud to issue certificate. So when your cloud is disconnected with Edge, they are on the same certificate chain. They can still do the validation of certificate, but when it is disconnected, you cannot issue no new certificates. But at the edge, you still can do the certificate authorization and validation. It's extending from center to edge. So for edge, you just do the simple decision. Would you extend to the controlling of external control?
And the actual status can be reported back through the subfield. And in risk condition, if you change some field value, there may be some problem.
In the current state of the project,
在这个项目现阶段，
to run a cloud
是会有
workload
可能
as well as an edge workload as part of the same cluster? Or is that
是不是可以在同一个集群，既在云又在边缘来运行代码，还是只是边缘？目前呢，如果在云上有集群，你可以 就用 KubeEdge 云组件进行做一个插件，然后你就可以有KubeEdge 连接。在我们展台的这个演示当中呢，这个应用程序是在圆圆的节点运行。这个音乐播放器呢是在边缘的节点。谢谢。So because time is up, I'd like to finish the session.